Hello everyone, today we're talking about the unit circle, section 5.1. So this section is going to be all about the unit circle, something you definitely should have seen before getting to pre-calc, so this should be a refresher in some cases, and then once we get to the end of the chapter, it'll definitely be more new material. So first, I'm going to remind you of the unit circle. All I ever concern myself with is the first quadrant. Because if you know the first quadrant, you don't have to memorize the whole unit circle, right? As long as you know pi over 6, my x value is going to be radical 3 over 2, my y value is going to be 1/2, that helps you with all the trig functions. Same if I know that if my reference angle, how far away from the x-axis I am. If it's pi over 4, I know my x value is going to be radical 2, my y value is going to be radical 2. And then I know if my reference angle is pi over 3, I know my x value is going to be 1/2, I know my y value is going to be radical 3 over 2. Since we're on the unit circle, on my axes, I'm at the point 1, 0, 0, 1, negative 1, 0, and 0, negative 1, so those are easy to know. And the unit circle equation is just the equation of a circle with a radius of 1. So if you know either the x or y point, you can go ahead and find either the other x or y point by easily plugging it into this equation. So I left this up here just for those that may not remember all of the different values at each reference angle. But we'll be using these for the remainder of this chapter and then into chapter 6 as well. So you really need to know this before we move on too far into chapter 5 and 6. So the first example is saying show that the point is on the unit circle. So like I was just saying, we know the equation is x squared plus y squared equals 1 for the unit circle. So I'm going to plug in for my x and plug in for my y. And if I square this, since it's division, I'm allowed to distribute that square. And since it's negative, but a negative square, it's going to turn positive. So we get a positive 4/9. We get a positive 5/9. So when you add fractions, you add straight across, keeping the common denominator the same. So we get 9 over 9. So we have proven this point is on the unit circle. Next, they're telling us that some point P is on the unit circle. They're telling us in this point P, the y-coordinate is 2/3, and the x-coordinate is negative. So, if we go back to our unit circle, right, we should all know that in the first quadrant, both x and y are positive, right? As my x values get larger, my y values also get larger, right? More positive in the first quadrant. In the second quadrant, my x values are negative, but my y values are still positive. In the third quadrant, my x values are negative and my y values are negative. And in the fourth quadrant, my x values are positive while my y values are negative. So in this example, they have said the y is a positive 2/3, and they have said the x-coordinate is negative. So when the y is positive, my x is negative, I must be in the second quadrant. So that's not really important to know for this question, but it is very important to know for later on as we go through the chapter. So I just want you to be aware for this question, this is taking place in the second quadrant, and we have to make sure that our x-coordinate is negative when we finish. So I know my y-coordinate is that. I don't know what my x-coordinate is. I'll rewrite the unit circle and plug in what I know. So then a little bit of algebra. Subtract 4/9 from both sides. And you get x squared equals 5/9. Right, 1 is 9/9, so 9/9 minus 4/9 is 5/9. And then take the square root. Whenever we take the square root, we get the plus or minus of that number. So make sure you remember that. You get the plus or minus when you take the square root. And since we are dividing, remember division or multiplication, you can distribute your squares or square roots. So I can make this radical 5 and square root of 9 is 3. But then our answer is not x equals plus or minus because they're telling us our point P, has a negative x coordinate. So that must mean our point P is negative radical 5/3 and positive 2/3 for y. So that's our point P. Next, they want us to find the point P. So they want us to find the point on the unit circle determined by the given value of t. So the first thing I like to do is I like to see what quadrant I'm in. Right? So what quadrant am I in? And then that should tell me my reference number. Right? And just like I showed you before, if you know your reference number, it's going to be one of these three values. So it's real easy. If it's one of these three values, you know the reference number, you just have to know whether you make the x negative or the y negative. So I would just memorize these three values, and then depending on what quadrant it is, you just determine which one's positive and negative. So 5 pi over 3. I always draw my axes. And here I haven't gone anywhere, right? That's the 0th degree. I haven't gone anywhere. Okay? So then it tells me I'm going 5 pi over 3. So that means I'm going pi over 3 5 times. Okay? And if you want to think pi over 3 is 60 degrees, since pi is 180 degrees. This is all stuff we should know. So I know that this is 0. This is pi over 2, or 90 degrees. This is pi 180 degrees. This is 3 pi over 2, 270 degrees. And then again, this is 0, or 360 degrees, right? If you do a circle, if you turn completely around, we got 360 degrees. So I've gone 1 pi over 3. That's 60 degrees. Then I go 2 pi over 3, 120 degrees. 3 pi over 3 would just be the same as pi, right? Because the 3's cross off. Then 4 pi over 3 is going to be in the third quadrant, and I have to go one more 5 pi over 3. So I can see that my point is going to be in the fourth quadrant, right? My reference angle, how far away from the x-axis? Well, I'm pi over 3 away, right? Because if I went one more pi over 3, I would have 6 pi over 3, or 2 pi also represents one whole circle. And this should all be stuff that we've learned before. So I can see that my reference angle is pi over 3. Okay, and if you haven't memorized your pi over 3, pi over 6, pi over 4, you can go back to the unit circle and see that pi over 3 gives me the point. And how I like to think about it, pi over 3 is 60 degrees. Okay, so pi over 3 is going to have the point, let's see, it is closer than it is long. So it's going to be the point 1/2 radical 3 over 2. Right, so pi over 3 is going to be 1/2 radical 3 over 2. Right, because I like to think of it, it's closer, right? It's obviously this number here is smaller than this number here. And that makes sense because my x value is 1/2. And radical 3 over 2 is my y value. That is longer than this. That's how I remember these the best. Right? My x value is shorter than my y value, so that must be pi over 3. That means 1/2 is the first is my x value, and radical 3 over 2 is my y value. So if that doesn't work for you, you can just memorize this, but that's how I like to think about it. So I know that this is the point 1/2 radical 3 over 2, but being in the fourth quadrant, right, 1, 2, 3, 4, my x values are going to be positive, so that stays 1/2, but my y values are going to be negative, so we should get that point. So this is actually my point. If I started at 0 and I went 5 pi over 3, the point on the unit circle that represents that angle is 1/2 for my x and negative radical 3/2 for my y. Next, they want us to find the reference number. Reference number, same as reference angle. So they want us to find how far this would be away from our x-axis. And these are abnormal angles, right? They're not divisible by 3 or 6. So they don't go evenly into 180. That's why we use 3 and 6 for 30 degrees and 60 degrees, and for 4 for 45 degrees, because they're divisible evenly into 180. So here for each one of these, I'm just going to draw like I did in the other one. So I know that this is 0 degrees, right? I haven't gone anywhere. And in this case, since my denominator is 5, I know that this is 5 pi over 5, right? Because all the way around is going to be pi. So this is 3 pi over 5. So if I want to think of this, let's see. I know this is like pi over 5 has to be here. 2 pi over 5 has to be here, and 3 pi over 5 has to be here. I think of it that way because 3 divided by 5 is 0.6, and so 0.6 is more than halfway from 0 to pi. However it works for you, we'd still have 4 pi over 5, then 5 pi over 5 gets us back down to a straight line. That's not what we're worried about though. We're worried about 3 pi over 5. So the reference number is how far away from the x-axis I am. Obviously this way is further than this way, so my reference number here is 2 pi over 5. I have to go 2 more pi over 5s before I got back to the x-axis. Same thing here with t. I'm going to draw my axes. 0 degrees where I start at. Now I know when my denominator is 7 that the other side is going to be 7 pi over 7. Right, so I could draw 7 pi's over 7, and we realized that we would get to 7 pi over 7. Okay, but then I've got to get to 12 pi over 7. So I've got 8 pi over 7, 9 pi over 7. Then we got to fit 10 pi over 7, 11 pi over 7. Then it would be 12 pi over 7, 13 pi over 7, and then obviously 14 pi over 7 would get us back to 0, because 14 pi over 7 reduces down to 2 pi, which is 360 degrees, one whole circle. But the question asks us for strictly when t equals 12 pi over 7, what my reference number would be. So here we can see we are 2 pi over 7s away from getting back to the x-axis. So 2 pi over 7 is my reference number, my reference angle. Mean the same thing, reference number, reference angle. So in this case, my reference number, 2 pi over 7, that's how far away from the x-axis I am. Now they've given us some numbers in, and I'm going to move these guys down. So we can fit right up here. So again, we have our axes. So these are just in radians already. So if you want to think of it, this is 0 radians. I haven't gone anywhere. Okay, pi over 2 would be, remember pi is 3.14, so that's 3.14 divided by 2. That would give me that number of radians. And just to give you an example, that is 1.571 radians. Okay, because it's pi over 2. This is pi, right? So halfway is pi over 2, all the way is pi. So that's about 3.1415, so it rounds to 2 radians. So 3.142 radians, and then the next one is 3 pi over 2. Okay, and 3 pi over 2 is 4.712 radians. And then also 0 would be 0 radians, or 2 pi, because that's 2 times around. You want to think of it, this is like halfway, all the way, to get to a straight line again, to get to a straight line again. So 2 pi's is 6.283 radians. Okay, so the first one gave us 3 radians. So we can see that 3 radians is somewhere in between pi over 2 and pi, right? Pretty close to pi. So if I wanted to figure out the reference number being how far away is that angle away from my x-axis, well, I have pi, so I'm just going to take pi, because pi is all the way back to my x-axis, minus 3. And we should agree that that'll give me the distance there from my x-axis back to my angle. And so when I do pi minus 3, so that's just 3.14, your calculator has a button pi. When I do that, I get the point, so I get the reference number 0.142 radians. And that's when I have an angle of 3 radians, right? So that starts here, goes all the way to here. I need to find the reference number, that's how far away that is from the x-axis, and that is 0.142 radians. So a very small angle is left. The next one gives me a -6 radians. So let's see if I can just... So a -6 radians means I start at my x-axis, but instead of going around counterclockwise, now I'm going clockwise. So 6 radians, right? So that's -1.57 radians. That's -3.14 radians. That's -4.712 radians. And then -6 radians is about right there. And what we need to find is how far away we are from the x-axis again. So to do that, I'm going to take my 2 pi. I'm going to type 2 pi into my calculator because I don't want to worry about rounding. And I'm going to subtract 6 because I know it's 6 radians. I know that this really was a -6 angle, but my reference numbers are always positive. I'll never have a negative reference number because the reference number is just how far away from the x-axis I am. So it can't be a negative value because it is a positive distance. So when I do 2 pi minus 6, I get a value of 0.283 radians. Okay, so I found my reference number. I found how far away these angles are from my x-axis. That's what we're always doing when we're talking about reference numbers. And finally, they've given us an angle. They want us to find the reference number and the terminal point. So again, I like to start off with my axes. So here I've gone 0, and this is 7 pi over 3, right? So if I've gone 1 pi over 3, 2 pi over 3, 3 pi over 3 gets me back to the x-axis, 4 pi over 3, 5 pi over 3, 6 pi over 3. Okay, then I still need to go one more, so pi over 3 is also the same as 7 pi over 3. Okay, that'll give me the same point on the unit circle, okay, because they have the same reference number. So I can see here that my reference number is pi over 3 because that's how far away from the x-axis I am. So my reference number, that wasn't a very good attempt at pi. And now that I know my reference number, I can find my point P. Right, I should have this memorized. So very soon we should have this memorized. That pi over 3, okay, I'm in the first quadrant, so they're both going to be positive. Pi over 3 is 60 degrees, if you want to think it that way. And I know that to be 1/2 radical 3 over 2, where, I'm sorry, pi over 3, 60 degrees, yes, that should be 1/2 radical 3 over 2. Copy it down on what I did. Yep. So 1/2 radical 3 over 2 should be my answer when I have a reference number of pi over 3. Okay, so if you want to go ahead and practice those 5 example problems that accompany this in the PowerPoint, we'll talk about this in class tomorrow. A lot here. I know there's a lot here, so please bring questions tomorrow. If you have some, work on memorizing that unit circle. See you tomorrow.